Okay, we are almost there. It's the final part of this lecture. The final part that will be all about dinosaurs, the best for the last. And let's start, of course, with some boring definitions. What is a dinosaur? And I know it can sound a bit easy. That question might seem easy, but if you've done the quiz just before, you probably realize that sometimes it's not that easy to know if what you're looking at is a dinosaur or not, and it comes from the fact that it's not easy to know what is a dinosaur anyway. So, for example, there's a common mistake of people believing that dinosaurs are always big, but they are not always big. Like, for example, this is Syntarsus from the Jurassic of South Africa, and the skull, that skull that you're looking at the moment is no bigger than my hand. So it was a fairly small animal. Uh, the name of a dinosaur also does not always have to end by saurus. So that might be the case in Encrebasaurus from the Jurassic of South Africa, found near Port Elizabeth. But it's not the case in, for example, Syntarsus. And it's not the case in many famous dinosaurs like Triceratops, Iguanodon, or Velociraptor, for example. So, another common misconception is that any extinct species becomes suddenly a dinosaur. So there are some people who call a mammoth a dinosaur, for example, just for the sake that it's an extinct species. It's not the case. It's not that simple. And especially those Mesozoic reptiles that lived alongside dinosaurs and that are also extinct reptiles are very often believed to be dinosaurs, and that's not the case. So there is one definition of dinosaur, two criteria that you need to have to be a dinosaur. These two criteria, these two features that you need to have to be a dinosaur is you have to be a reptile that do not sprawl. Oh, and by the way, sprawl with a L at the end. So you have to be a reptile that do not sprawl, that does not sprawl. And for this, you need to have a dry skin with scales, like a reptile. So that's the first criterion here. And you need to have legs that are straight under the body. That's what I told you in the previous video. So legs that are straight under the body is the characteristic of dinosaurs. So dinosaurs are the reptile that walk upright on their legs. And if you look at this chicken that you've seen in the quiz has scales on its feet, and its feet are right, and its legs are right under its body. So by definition, this chicken is a dinosaur. It conjugates the two characters of the dinosaur, of the dinosaurishness, if I can say. So, and the fact that birds are dinosaurs, it has been long known since the discovery of Archaeopteryx in the Jurassic of Germany, which was in 18, I think it was in 1859 or 1860, something like that. So in 1860, Archaeopteryx was discovered in the Jurassic of Germany, and Archaeopteryx allies a dinosaur skeleton with bird feathers. So the dinosaurian characteristics of its skeletons are its claws. You can see that the hands have tiny claws, and I encourage you to find pictures on the internet that are high resolution enough to see those claws on its hand. So unlike birds, but like dinosaurs, the hands have big claws. It has a very long tail also, which birds do not have. In birds, the tail is very short. The feathers can be long, but the bony tail is very short. And the skull is the archosaur type. So it's completely the same skull as that of a crocodile, with the orbit here Behind the orbit, you have 2 temporal fenestra, like a diapsid, and in front, you have an antorbital fenestra, like a crocodile. So, and on the mandible, here the region of where you could find the mandibular fenestra, unfortunately, is broken, so it's not easy to see. But the very presence of an antorbital fenestra already tells you that it is an archosaur skull, because only archosaurs have this antorbital fenestra. And also, if you look carefully here, you find teeth that are completely absent in birds. So all in all, you have the skeleton of a dinosaur with the feathers of a bird preserved around it. So if you find the skeleton of an Archaeopteryx, but the bird feathers are not preserved, you will probably say that Archaeopteryx is a dinosaur. If the feathers were not preserved, you will probably say this is a dinosaur skeleton, this is not a bird skeleton. And that's another very nice example of transitional species, of intermediate species, and that's another major transition in vertebrate evolution, the transition from reptiles to birds. So birds actually are descended from dinosaurs, so birds by definition are also some kind of dinosaurs. And now you may remember the last lecture, the lecture on the South African fossil hunter. I told you that the Khoisan made a cave paintings in which a dinosaur footprint was represented, and in which and that was accompanied by those 3 figures, those 3 silhouettes, and these silhouettes were very bird-like in appearance. And now you realize that the reason they were bird-like is because they were, and I told you, sorry, that the reason they were bird-like is because they were looking at the footprints, left no tail dragging on the floor, and they indicate that the animal was bipedal. Also, if you are very observant, you can compare these footprints with these dinosaur footprints to the actual foot of a modern bird, like an emu, and you will see that the foot of an emu perfectly match with the footprint of the dinosaurs. They have the same type of foot with 3 big fingers, and the middle fingers being the biggest of all. So that's no chance. It's because birds are directly descended from dinosaurs. And now we are going to look at the fossil record of dinosaurs in Africa. So not the complete fossil record, but at least the most important dinosaur fossils that you find in Africa. So probably you were not aware that dinosaurs were found in Africa, but actually there are a lot of dinosaurs in Africa. Africa has an amazing fossil record of dinosaurs, including probably what is the oldest dinosaur known, although it's quite debated, of course, because the material is not perfectly preserved, and there's always some debate on who's got the oldest dinosaur. But one of the candidates, and the most favored candidate, is Nyasasaurus from the Triassic of Tanzania. So this would be the oldest dinosaurs, the first dinosaur that ever lived. And then you have 3 big families of dinosaurs. The first family of dinosaurs is the Ornithischia. The Ornithischia are the herbivorous dinosaur, the small, may I say, herbivorous dinosaur. These dinosaurs are characterized by the presence of a beak. For example, Triceratops was a member of the Ornithischia, and the duck-billed dinosaurs were also member of the Ornithischia. And in South Africa, we have examples of herbivorous dinosaurs like Heterodontosaurus from the Jurassic of South Africa and Lesothosaurus from the Jurassic of Lesotho, as its name indicates. So these 2 had a beak at the top of their mouth, and they had teeth that were adapted for an herbivorous diet. And those ornithischia are found from the Jurassic to the Cretaceous, and they become dominant in the Cretaceous, dominant over the other group of herbivorous dinosaurs, the Sauropoda. So that's why I told you these ones are the small herbivores, because now we are talking about the big herbivores, the very, very big herbivores like Giraffatitan from the Jurassic of Tanzania, which is one of the largest dinosaurs ever found, with a body mass estimated to between 20 and 60 tons. So that's a gigantic animal. 60 tons, it's 10 times an elephant. So 10 elephants, 10 African elephants are just a match to one Giraffatitan. And this one was discovered in Tanzania, in the Jurassic of Tanzania. So that's why I've told you the previous one were the small ones. These are the big ones, the sauropods. So they are usually very, very big and with a very long neck and a small, small head. Very tiny head at the top of a very long neck. And you find them all over the world, including Africa, and particularly you find one example in South Africa, which is Ledumahadi mafube, so the thunder dinosaur of Africa. And this Ledumahadi mafube was the earliest very large relative of sauropods. It was the first dinosaur to reach beyond 10 tons. And it lived in the Jurassic, in the early Jurassic. So it was more or less the ancestor to the Giraffatitan of the late Jurassic. And these sauropods are quite interesting because they originated in the Triassic, and they ruled the Earth in the Jurassic, and then they got dominated by the duck-billed dinosaurs, so the Ornithischia, during the Cretaceous. So if you find the duck-billed dinosaurs, you're almost sure that you're looking at Cretaceous rocks. But if you find a sauropod bone, a very large sauropod bone, you're almost sure that you're looking at a Jurassic rock. And also the sauropods are well known, particularly the South African sauropods are well known for giving the oldest dinosaur egg in the world. This is the egg of Massospondylus. You've seen it during the first lecture. So that's the embryo, and the egg is around it. So it's a perfectly preserved dinosaur egg from the Jurassic, and it's one of the oldest dinosaur egg in the world. And that's what the adult would look like. So the typical long neck with the small head and very large claws. And finally, the carnivorous dinosaur, the third group of dinosaurs are the Theropoda or Theropoda. So the Theropoda are your carnivorous dinosaurs from quite small to medium sized to very large size, the largest of all carnivorous dinosaurs being also the title of largest carnivorous dinosaurs being also held by an African species, Spinosaurus, which is found in Egypt, in Morocco, and in Niger, if I'm not mistaken. So in northern Africa. And it's actually larger than its most famous cousin, the T-Rex. So you can check that on the internet, Spinosaurus. It was also made famous by the Jurassic Park saga. And like all other theropods, it is characterized by its meat-shearing teeth. So very sharp, just like Syntarsus here, for example, from South Africa, you have recurved, very sharp meat-shearing teeth. And all theropods have this kind of teeth. So Syntarsus from South Africa and Zimbabwe is a theropod, and Anquibasaurus from the Jurassic near Port Elizabeth, from the Cretaceous actually, near Port Elizabeth. That's a mistake on my side, and I must correct it right now. Cretaceous near Port Elizabeth is also a theropod. And in southern Africa, we also have very large theropods. Syntarsus and Incubsaurus are very small theropods, but we do have footprints of a very large theropod called Kayentapus that are found in Lesotho. And this is what, based on the size of the footprints, this is the size, the estimated size of the carnivorous dinosaurs that made them. So we are still looking for the body fossil of that animal, but you can already see that this animal was pretty big. And all dinosaurs became extinct during the end Cretaceous mass extinction. So another of the big five mass extinction. This one happened 66 million years ago, and it saw 75% of all species become extinct. So it's a least important mass extinction than the end Permian mass extinction, but it's still one of the big five. And this one is probably the most studied of all extinctions, of all mass extinctions, for two reasons. The first one is because it's the most recent of all big five. 66 million. There hasn't been any mass extinction since 66 million years ago. Sorry. And the other reason is that it's the mass extinction that wiped out the dinosaurs, the very famous dinosaurs. So it constitutes the limit between the Mesozoic and the Cenozoic because it's such a dramatic event. And there are still a lot of debates around the reason of that mass extinction. Some people saying that volcanic activities in India triggered the mass extinction, and some other people saying that it was a meteorite falling in Mexico, so in the Yucatan Peninsula in Mexico, that triggered the mass extinction. So this is the site where people think the meteorite fell in near Mexico. You can see in Chicxulub. And one noticeable thing about the Cretaceous Paleogene mass extinction, or end Cretaceous mass extinction, is that the stratigraphic section that serves as a global reference for that boundary, the Cretaceous Paleocene boundary, is actually located on the African continent. So every time a scientist, a geologist want to study this very popular mass extinction, this scientist has to come and check if his theory can be verified on that particular stratigraphic section in Africa. So it's located in El Kef in Tunisia, and this is, for example, the count of foraminiferans. So the foraminiferans are small single-celled organisms that live in the ocean, and they have a very nice fossil record because they produce a shell that is called a test. And so you can see when did this foraminiferan become extinct across the stratigraphic section. So that's the stratigraphic section. The Maastrichtian is the last stage of the Cretaceous. The Danian is the first stage of the Paleogene. So that's your mass extinction. And you can see here how massive is that extinction. You have really all those foraminiferans that lived in the Cretaceous suddenly are wiped out, just like the dinosaurs, at the limit between the Cretaceous and the Paleogene. And then slowly, some survivors carry on, and slowly new species are evolving and are filling up the empty space. So that's why this is the typical stratigraphic section. It's because it's so clear what's happening there. It's so clear how the mass extinction is happening here. And also you have this dark horizon. So that's the lithology here. And you have this dark horizon that corresponds to some clay that were deposited at the moment of the impact. And you find some remnant of the impacts that were projected from Mexico to up to Africa. So melted pieces of rocks that were melted by the impact have been projected all the way to Africa, and you find them in that layer of dark clay. So that's why we have the typical stratigraphic section here at El Kef on the African continent. It's because the message here is very clear. There's no doubt about what's happening there. And so I told you earlier that mammals were living in the shadow of dinosaurs still until they evolved in the Jurassic. So they were very small, nocturnal and insectivorous animals. This is very well illustrated here. They looked like rats or shrews, and they were very, very small and very, very discreet. And suddenly the world, all the dinosaurs in the world are wiped out, except the birds, of course, because if you consider birds as dinosaurs, the birds did survive. But all dinosaurs become extinct 66 million years ago, and suddenly the mammals are all alone. And these ancestral shrew-like mammals began evolving and diversifying into all that diversity of mammals that we know today. So this is the Cretaceous, this is the Cenozoic, and from the beginning of the Cenozoic, mammals will diversify into all those diversity of mammals. So carnivorous, herbivorous, flying, swimming, arboreal, anteaters, all of that. So this all started with this shrew-like type of mammals. And because the dinosaur left the empty space behind them, there was no longer big herbivores, there were no longer large carnivores or flying. The flying reptiles also become extinct, the pterosaurs, and the marine reptiles also become extinct, hence leaving space for whales to evolve. So all these big reptiles that dominated the Mesozoic become extinct suddenly 66 million years ago. So we're moving into the Cenozoic, the age of mammals. All the reptiles that lived in the Mesozoic are gone, and now the mammals will dominate. And among those mammals, there is one particular group called the primates, that have a very particular evolution. So primates are easily recognizable in the fossil record because of their binocular vision. So their eyes are located in front of the skull, not on the side of the skull. So the eyes are in front of the skull and not on the side. If you look at a horse, for example, the eyes of the horse are located on the side. If you look at a parrot, like a bird, or any bird, you will see the eyes are located on the side, but not in primates. In primates, the eyes are located in front, on the face. Primates are famous for their big brain. Their brain is in average bigger than any other mammal of similar size. The thumb is always opposable in primates. So this is what you can see on this picture also. The thumb is opposable and can grip stuff. And primates also have nails. They don't have claws, they don't have hooves. So they don't have claws like carnivores, they don't have hooves like herbivores, they have nails. And the nails are typical of primates. So that's how you recognize a primates. All primates are arboreal and they more or less live close to the tropics. There are a few exceptions, and humans, for example, are an exception, but most of the 300 species of primates live in tropical areas. And so the primates began evolving in the Cenozoic, and you can divide them into three groups. First, the lemurs and bush babies. So the lemurs that you find in Madagascar and the bush babies that you find on the African continent, they belong to the family of wet-nosed monkeys. So the wet-nosed monkeys, because they have that black thing at the top of the nose that has that they have to keep it moistened, just like dogs or cats. And then you have the dry-nosed monkeys, or simply the monkeys, the proper monkeys. Those dry-nosed monkeys, that's where you find your baboons, your macaques, and that's also where you find humans, because we humans don't have a wet nose, a very black and moist wet nose. We have a dry nose like this. And finally, you find the third family, which is the apes, and that includes the hominins that Schobard and Horst will talk about in the next lecture. And these hominins are characterized by the coccyx. So the coccyx, it's the terminal bone of the vertebral column. So we go back, finally, full circle. We started with the backbone and we end up with the backbone, because the coccyx is the result of the fusion of all the vertebrae of the tail. So if you look at a lemur, for example, it has a very long tail, and most monkeys have a very long tail, but not apes. Apes have a coccyx instead of a tail, and this is the result of the fusion of all the vertebrae of the tail into one large bone. And those apes are only found in the Neogene. So the primates are found all throughout the Cenozoic, but apes are only found in the Neogene since 20 million years ago. And the human lineage, the hominids, appeared 7 million years ago, but this is the story that Shaw will tell you. So this is the end of my part for the origins of life. Thank you very much for keep looking at it. Thank you very much for being brave enough to follow this course online in these difficult times of lockdown. I hope by the time I finish, well, I hope by the time that video is being watched by you, the lockdown is over. But if not, well, this is still difficult times. And I just want to show you that picture, which is a picture of a whale called Togocetus that lived during the Neogene. And it's just a very nice picture to show you that the history of that we've just scratched the surface of the evolution of life and how Africa documents the evolution of life. We've just really scratched the surface. We did not go very deep. There's a lot more to know, and there's a lot of other fascinating stories, like the evolution of whales and like the evolutions of so many dinosaurs that are found in Africa. So I hope I will see you again. Maybe if you want to do your honors, maybe if you want to study paleontology, if you want to volunteer at the Evolutionary Studies Institute and work on fossils with us, you will be more than welcome. So once again, if you're interested, just send me an email. Thank you very much.